Hi guys, I'm Dr. Ganesh. We have been trying to learn machine learning and I have been trying to share my knowledge on machine learning uh, through this series ML Demystified. In the previous video, we have seen entropy and information gain. Entropy, to get a quick recap, is a measure of disorder or impurity, uncertainty, and the goal of machine learning is to reduce uncertainty. Whereas information gain is how the entropy decreases after the data set is split, and where we get maximum information gain we should choose that node to decide. One of the most popular and old algorithms in machine learning decision tree category is ID3 algorithm. It is called iterative dichotomizer tree. The algorithm iteratively and repeatedly dichotomizes, which means divides, features into two or more groups at each step. It's a top-down greedy approach to build a decision tree. So the top-down approach means that we start building the tree from the top. Greedy approach means that at each iteration we select the best feature at the present moment to create a node. A high-level explanation of ID3 algorithm is here. We calculate information gain for each feature. Considering that all rows don't belong to the same class, split the dataset into subnodes using the feature for which information gain is maximum. Then make a decision tree node using the feature with the maximum information gain. If all rows belong to same class, make the current node as leaf node with the class as its label. Repeat for the remaining features until we run out of features or the decision tree has all leaf nodes. Let's take an example on Corona, the COVID-19 prediction. Thanks to this particular article in Towards Data Science Medium, which from where I have taken this example. Thank you author for and the full credit of this example goes to them. So the dataset contains three features: fever, cough and breathing issues, from which the existing data of COVID-19 infected or not data. The three columns fever, cough and breathing are actually called features, and the final column called infected is actually the target column. First step is to find the best feature which gives maximum information gain. So to calculate information gain for real features, first calculate entropy. From the total 14 rows in our dataset, there are 8 rows with target value yes and 6 rows with target value no. So the entropy is 8 over 14 log 8 over 14 minus starting with minus by the way. Minus 8 over 14 times log 8 over 14 minus 6 over 14 times log 6 over 14, which gives 0.99. Then let's take feature by feature. For fever, when we take, there are 8 rows with value yes and 6 rows with value no. In the 8 rows with yes for fever, there are 6 rows have target value yes and 2 rows have target value no. Similarly, in the 6 rows with no for fever, there are 1, 2, 3, 4. 4 nodes with the target value no and 2 nodes with target value yes. So we can calculate the entropy for these two subsets yes and no, and then calculate the information gain by calculating the original entropy minus the S yes divided by S times entropy minus S no divided by S times entropy. So the information gain for fever is 0.13. So the tree has been made with the breathing issues as the field. Now next repeat the process. From the remaining unused features, cough and breathing cough and fever, decide which is the best for the left branch of breathing issues. The left branch of breathing issues is yes. So we take all columns with the breathing issues yes. Only among them analyze fever for yes and no, cough for yes and no. So breathing issues yes is SBY, and then calculate the same information gain for fever and cough separately by calculating the corresponding entropies, and then we get it as zero point 0.2 and 0.09. So see that fever gives a better information for breathing issues yes, so the tree has been split. Now ID3 says unused feature should be examined next, so we will take cough. Since there is only one unused feature cough, and see that when breathing issues is no, breathing issues is yes, all irrespective of cough value, everyone is infected. So for the right side of the fever, we see subset of rows from original data. Again, most of them are infected when breathing issues yes, and okay. So repeat this process, but we do not have any more features. It's all done. So you can see here something interesting, something strange. When the cough, once breathing issue is no, irrespective of cough, that person is not infected. So that is a strange factor, but this particular algorithm does not take care of that. So this is one of the drawbacks. ID3 doesn't do pruning. You remember pruning? Pruning is actually defined as uh, can we reduce the size of the tree by removing some unwanted fields. So here ID3 algorithm finalizes the tree as this. However, we can actually reduce a tree to this by pruning. So it's a mechanism that reduces the size and complexity of the decision tree by removing unnecessary nodes. Another drawback of ID3 is overfitting or high variance. That is, it learns the data set it used so well that it fails to generalize on new data. There are many other algorithms developed after ID3. One is C4.5. It's a successor of ID3 and removed the restriction that features must be categorical by dynamically defining a discrete attribute, which partitions the continuous attribute value into discrete set of intervals. So it converts the trained trees into set of if-then rules, and the accuracy of the rule is evaluated to determine in the order in which they should be applied. Pruning is done by removing a rule's precondition if the accuracy of the rule improves without it. That is a highlight. There is also an algorithm called classification and regression tree CART. It is very similar to C4.5, but it differs that it supports numerical target variables and does not compute rule sets. CART constructs binary trees using the feature and threshold that yield the largest information gain at each node. A quick difference between these three. So ID3 splitting criteria is information gain. For CART it is towing criteria, and for C4.5 it is gain ratio. I request you to learn the other splitting criteria. We may not discuss them here. Then ID3, the attribute type, it handles only categorical value. Both CART and C4.5 can handle both categorical and numerical value. When ID3 does not handle missing values, both other algorithms can handle missing values. While ID3 does not have any pruning, the other two has pruning, but in two different ways. And ID3 may be susceptible to outliers, whereas C4.5 also, whereas CART can handle outliers. What are different types of decision trees? We already said about it before. There can be classification trees or regression trees. So to classify means response variable has only two categories. Use a standard classification tree, such as ID3. When the response variable has multiple categories, probably C4.5 is a better algorithm. And decision tree, when it is used for predicting something, the response variable is continuous. So when linear relationship between predictors and response exists, use a standard regression tree. When it is not, which means non-linear relationship between predictors and response happen, use C4.5 implementation. To summarize, in this video I explained ID3 algorithm thanks to Yasser Sakaf and this article here which gave us such a relevant and timely example of a corona dataset to learn such a powerful algorithm in a simple way. And we will see with more algorithms in the future videos. Bye.